Oh yeah, good afternoon. So I'm Brian Haddock. I have done stuff with John before, Cybernetics, last year enough, but so I'm head of the weather resilience systems operator of the network at a national level. My colleague Jay is going to talk to you about regional level in a second. But that in itself is part of my problem statement that I won't get onto just yet, but I'll be quick. So I lead a team that looks at weather resilience, and we work quite closely with the climate change adaptation team, but most of our work is hugely reactive. We've been trying to be proactive and preventative for a long time, hence why we're developing a season agnostic railway model. Sam, John, who I've worked with for a long time, who we work together on Tomorrow Railway and Climate Change Adaptation Tracker here with Arab way back. I'm not quite sure what the railway have done with that work, but that's £3 million worth of good work there. So I'm going to keep this really brief. I'm really difficult. I'm really not very good at keeping things brief. So I'm going to talk about the challenge, why cybernetics, and the outcome, and for who, which for me is the key question about all of this stuff. One of the things that we deal with all the time, and I'm not going to talk too much about data because I know Jay's going to cover some of that stuff off, but it's well known within the railway that we've got tons and tons and tons and tons of data, and invariably none of it talks to any of it. Most of the systems don't talk to one another. That includes remote condition monitoring, telemetry, all sorts of things that are out there on the track, things that are on the train, systems we've got internally within Network Rail, and how we understand delay, which is what I'm going to talk about a little bit. Why cybernetics? Basically because I met John a few years back. And outcome for who? Again, why are we doing this and who is it for? And that isn't really easy to answer, okay? Because there are so many customers to this. It should be the passenger and the freight user, but most of the time it isn't. So, catches up, isn't it? So what are the sort of things we deal with? Some of you may have seen this slide before, sorry, I apologise. But just in regards to the sort of typical things that we see, trees on the line, flooding, trampolines, our line-side neighbours cause us lots of problems, but of course that we work very collaboratively with them until a building site's leave bits of plastic that hit overhead line equipment. It's interesting, the vulnerabilities to the railway. If you look at that picture at the top there, most people look at that and say, well, surely you can run a train through that. Yes, you can. Of course you can. There's no problem running a train through that. But we don't. Simply because we're concerned that it's affecting the signalling equipment, all the other asset stuff that combines as a compound issue for us. So we don't. But actually, that causes probably far more delay than that, because a little bit of plastic float, I think this was a 20-mile-an-hour gust, roughly. This is on the contact wire or the catenary wire. I can't see from that shot. But this cost somewhere around, I can't remember how many minutes, but it was into the thousands of minutes delay. And if you equate that with roughly about £75 per minute and above, and then all the reactionary delay, just a little bit of plastic can cause, so you could probably argue that's not even a weather event. It's a 20-mile gust, which we get lots of. Trees, there's a lot of discussion around trees. Just to give you some of the politics of it, we have lots of trees on our own estate that we manage. Then we have trees on third-party estates, which we don't manage. So if we get a tree like this, we say, is it this side of the fence or this side of the fence? Because if it's that side of the fence, it's not necessarily our problem, but it is still our problem. But there's lots of discussions about how we report. Other things that happen, hot weather causes buckles to rails, low adhesion caused by leaf fall. That's the output of that. We get flat tyres, all sorts of things. Problems with track circuits. So it's not just trains slipping on the rails, it's all sorts of other things. The things with fleet themselves as well. So that's a coupler impacted with snow, so it's difficult to actually connect with other trains. And then you get freezing around shoe gear. And of course, in the southern region and part of Merseyrail, you've got the third rail, which you train your current from for the traction motors. The slightest bit of ice on that will compromise the draw into the traction itself. So the train invariably stops. We've got clever trains that are so clever now that they switch themselves off so they don't break their electrical quick. So just a John can So they're the sort of issues that we get every day, but they're not the issues I want to talk about at all. That's almost irrelevant. Because for me, this is the big issue. This is an old organisational chart, so don't look at the names on this. But at a national level, we're a devolved entity, right? So we've got regions, 14 regions, 5 regions. But nationally, just nationally, the national function of Network Rail as it stands, and actually, if you take this as the rail industry, it's wider than just Network Rail, but I want to talk about just this bit in particular. You can see here, you've got network operations, maintenance and operations at the top here, and then you've got infrastructure projects, renewals and enhancements, right? And then safety technical engineer at the top, where you draw a line through that straight away, okay, because they're separate functions. And the operations is pretty much, as you imagine, it's day-to-day, lots of the controls. And we deal with lots of things in real time. We have to dynamically adjust on the basis of most of its tacit knowledge by the controller at the time. So, time up there, the technical authority looking at policies and strategies, long-term stuff around climate change, and also seasonal plans, what we're going to do for winter, summer, autumn. But actually, on a day-to-day basis, we're down here dealing with the incidents, and they don't always match up. And then you've got infrastructure projects and renewals, which are completely separate entities again. And that actually, you know, the feedback between me and the issues, this will be my proposition at the end. So, if we look at that structure and then look at a typical kind of cybernetic organisation, which John and I talk a little bit about the seismic railway model in a second, but it's a very different way of looking at this. This dynamic adjustment does happen in operations. It happens every day in operations. But actually, it doesn't happen at policy level. It doesn't happen at all at major infrastructure projects and within technical authority function that look at the bigger picture in planning. Because the dynamic adjustment is really, for us, is very reactive. So we killed 3 people up in Scotland in COVID with a HST that came off with a landslip. We are now in this dynamic adjustment, 2.5 years beyond that, still trying to work out what we need to be doing, building forecasting systems, etc., etc. That's about as dynamic as it gets when you look at the longer term. Otherwise, the dynamic adjustments are what we do in control every day based on a forecast. And the weather forecast is something that we contract with a weather forecast supplier that we do try and prepare and plan for, but we're not very good. And the reason why we're not good at this is because it goes back down to all the divisions we have. At the moment, we have this thing called delay attribution, which is revenue. It's about revenue. It's about who's to blame, what's the root cause, where does that, who gets fined by who. That's why I go back to that tree bit. If that tree is on one side of the fence, it's different to being on the other side of the fence. Okay? And it's down to that level of detail reporting. So why are we reporting that? Because it's revenue. Is it about for the benefit of the passenger? Not really. You could argue it really is. It's actually internally about where we draw the cause from. But when it comes to weather, most of that cause, if you take this weekend, for example, up in Scotland with Storm Haddock, there'll be people in control being bombarded with information about incidents going on. Trains stopping, drivers reporting they can't go any further because of flood, or there's a tree on the line, or the embankment slipped. And all this information is coming into control. Invariably, one person taking all this information into account and plugging it into a computer, saying this is all written into a computer, into a system, telling us what the root cause is at that time. It all builds up. All builds up. And at some point, somebody will say, well, it was down to the storm. So they'll press a button and we'll go to the storm. A whole lot, all that information goes off to that storm. So we've not got any ability to go back into that properly and sift it out because it's all freehand text. None of this is coded, but the codes are really, they're limited. So instead of just moaning about it, I wrote a paper to our executive to say that we've got to be brave and we've got to say that the attribution, certainly for weather management in network rail and the rail industry actually at wide, is not good enough. It doesn't give us detailed information. It certainly isn't good enough to build a business case for resilience. So, talking with John, we built this idea of the seasonal agnostic railway model, and it's very dependent on these inputs. Now, One of the outcomes of the train crash at Stonehaven was that our forecasting area was geographic. So we forecast over a large area. A lot of it hasn't even got a railway line on it. The railway line goes through bits of it. And what we needed to do is understand at a local level where the forecast was and the impact of that in terms of the weather, not the impact on the railway, just to understand what parts of the network were being affected by rainfall, for instance, and come on. So we developed what's called operational route sections. And those operational route sections are generally from signal to signal or to a station, so that we've got the ability to inform the driver if we're getting a forecast in real time, as close to real time as possible, of the convective rainfall. No other weather parameter, just for the convective alert tool, for convective rainfall. Using those operational route sections, we start to build this model where we're looking at asset information, real asset information that's in those operational route sections. And there are lots and lots and lots of data points in there. I can't remember, John, 30,000 points per operational route section. You aggregate them. And then once they're aggregated in this model, then it will start to tell you their overall impact on individual trains that run through that section. It's a completely different way of doing it. And that's what this system, I won't go into the details, you ask John later. But there's 6 dependencies there of information that sits into the model, which comes up with the different options. And the decision still lies with the control about what option they're going to take. But of course, if you do this properly, you can create an amended plan well in advance, months in advance, that at that decision, you implement it on a forecast of the expected weather of whatever it is, because we've got thresholds that are breached. If they get breached, that decision is made. That enables this bit. Yeah, it enables information going to passengers. So I was head of the National Operational Centre for my sins a few years back, and I remember being literally coming out the office at Milton Keynes, being on the station, looking up at the board, the information board, it was blank, and I was head of the control, and I didn't know why that was blank, and I didn't know where my train was. Yeah, so because nobody did, and that, or if they did, they haven't been able to communicate it across. In that space, that spatial temporal time, it just doesn't happen. But if you know you've got a weather event coming, like Storm Weather, which we did this really good forecast actually for that weather event, we could have easily put in a timetable. Scotland chose to actually withdraw a lot of their services, to be fair, and cancelled lots of services, as you would expect after what they've been through recently, and they had a lot of flooding. But this bit, for me, is the key. It's actually, to be resilient isn't necessarily, we're not going to spend billions of pounds on our infrastructure. It's just not going to happen. So what we do need to do is an agnostic railway where we've got a plan that actually matches what we think is a forecasted event. But we can't do that unless we know the impact. And this model starts to tell us what that impact is.
With the others, we'll straight on. I'm going to introduce Jay Nasir. Jay and I met about a month ago with a bunch of the other people working on some at the Romford Rock, as we will call it, the Good Operations Centre just east of London. And I put it, Jay, that you're responsible for everything that happens on the railway east of London.
Well, I hope so. Some safe hands. Thank you for introducing me. So, Juwad, Jay, in the rail industry about 18.5 years. Started my career as a signaller pulling levers. So, we still have levers and bell codes, which we use to communicate how to move trains forward. Fast forward that, we also have a digital railway. So I'm here today just to give a different spin, try and give you an overview from my understanding and also from our industry. Got my phone out with some notes on it as well. So Brian mentioned from a national perspective, I come from a regional perspective itself. So I'm based in Anglin, which has 14, which is one of the 14 routes. We run just over 4,000 trains a day with 2,600 employees. So from a command and control perspective, day to day, everything's different. So you see a tree on the line, you see a flooding, you see a passenger fatality, you name it, we deal with everything. Everything comes into a control center, which is the hub itself. Take a history journey with the growth and the automation in making better informed decisions for our passengers. Back in the days of the 18th century, the UK pioneered the railway through a steam locomotive process, 2-track railway up and down, and it was revolutionized. Worldwide, it was one of the best things that ever happened. And then we started to increase in terms of the level of service, what we needed. But what we didn't change was the way we think, the way we operate, and the way we deliver for our passengers. One of the things that you notice if the train is from an old train here, you'll see a signal, which is a semaphore signal, which is like a plate rectangular, which is out of the ground, stops the driver, preventing the driver to go ahead. So you are providing some advice to the driver visually outside. We obviously gone forward now into the 21st century with digitalized trains. Now we've changed those semaphores into digital lights. What we haven't actually done is that what our need is, and is that sustainable for the future? Is that the right information to digitalize? We talked about digitalization earlier on, we talked about net carbon, etc. What we haven't changed is the passenger numbers have soared and the freight transport becomes a very economic driver for the UK itself. So there's been a big host around that. But does modernisation stop there? So we go from the 18th century to the 21st century, new trains, great, new Wi-Fi on there, better luxury journey experience. But really, is it actually luxury? Does it provide you with what you want? When you have Google Maps on your phone, and you're trying to find a way in a car, it tells you an alternative route because there's disruption on the network. Why can we not, as an industry, walk into a station with analytics telling me on a season holder ticket, it's disruption on my network? With push information. If Facebook, Google, Instagram, Snapchat can already do this, why are we becoming the later adopters of the industry itself? Moving on, we did a piece. Well, I was quite fortunate. In 2020, when I came back into operation, I was given sort of a free will in terms of a license to operate. We changed the way we model as an industry. We set up an industry where you have 2 line managers managing 90 people for competency, operational delivery, safety, HR details. No process, no tech, nothing. We've never changed. That's been since 1990s. Coming in with a hammer, smashing that box, starting from bottom up rather than top down, we created an SME group, which enabled us to change the way we want to operate. The cases for change were external pressures such as the Office of Rail Regulator, the current ops structure didn't work, the one I've just explained, increased interventions. There was no career pathway. So I came from a frontline operations role. Either you take a promotion based upon if someone passed away or if you knew someone. There wasn't a proper pathway out there. So now with the Child Institute rail operators, you've got a proper pathway which enables people to grow their career with actual educational background, with theoretical knowledge as well at the back. Same time, COVID hit us. It's also about attracting our passengers. Why do passengers want to come back to the railway? What is it we can offer them? Why can't they use an aeroplane? Why can't they use a bus? How do we stay present and valued in today's world? We then obviously embarked this journey of this whole program in 2020, as I mentioned. This has been a painful journey with lots of successes, but this hasn't solved everything. It's about continual learning. It's changing the dynamics how the rail industry operates, changes, and responds. We worked on a process, tech, and people. We worked on those 3 P. The people is people drive your business. People deliver your railway today. That's the philosophy we had. The technology was adapting to technology such as traffic management, which will allow predictive 8-hour ahead currently of what the railway could look like. So you could put interventions in and say there is a speed restriction or a disruption further down the lane. I could input that into the traffic management system and it will calculate the actual performance impact, which can calculate financial impact, which can then also force our maintenance colleagues to actually clear a railway much quicker than anticipate rather than waiting a week. In the prior world of traffic management, finger in the air, based upon my experience on the railway, the disruption will be based upon this. If I'm new in the railway, my experience will be limited and I will have a voice, but it will be slightly different than someone who's more experienced. So the technology piece helped and embedded very well. Process piece, there was a clear structure of command and control. Who was in control of the incident, who was delivering the outputs, and who was leading in terms of the strategy. The hunger for information. So talking about the people process, it provides us with some foundation. But the industry is filled with so much automated information. Train operators run with information. We've got information as our own information. We have other organisations which form part of the railway have information. What we need to do is have informed decision making, a predictive maintenance, enhanced safety and passenger experience. It's about having access to real-time data. There's so much data out there, but what do we do with that data? Working on Brian's analogy such as the weather. We know what the Met is going to say. We know we're going to have 4 seasons in the UK. We get a piece of data information. We hold an emergency weather teleconference with all the SMEs. We tell them what the weather is. Then an SME on the other line would say, right, based on my 20 years experience, I'm going to say we're going to put a 30-mile lamp because that's what the standard states. How do we continually learn from that? How do we make this automated, which gives you, or the operator who's taking those 100 phone calls in, to make the right decision at the right time? Obviously, history shows that as an industry, we adapted to create and think beyond the 18th century. Today's a present example. We are here as system thinkers from different backgrounds. We can create and think openly in terms of that. The demand growth has to incorporate the passenger experience. We also need to involve our people as part of the journey to achieve an embedded culture of continuous improvement. Organizations sometimes do it top down, and CEO coming in, we talk about how network rails align is we work in control periods, which are 5-year control period, which then aligns with the government's 5-year. So therefore, we're funded by a paymaster who only sees a short-term goal from year 1 to year 5. I invest from short term. But then what's so sustainable? How do we get to net growth zero? We talk about sustainability. How do we encompass all of that as a strategy itself? We have to acknowledge that information has an importance in today's world. However, what we do with that information is critical in how we make better informed decisions. To end this was my question. How can the rail industry leverage the abundance of data available through digital transformation to enhance passenger journey experience and safety by enabling swifter decision-making process? Bit of a handful, but hopefully I'll pick it.
Thank you very much.